All right, let's look at the homework 1.6, problem number 4. All right, so we have this piecewise defined function. All right, then we want to find the intervals on which this function is continuous. All right, so you can see that the first function is just a quadratic function, which is continuous by itself. And the second formula is a linear function, which is just going to be a straight line. So it's continuous by itself. All right, the only place that could have discontinuity is at the gap between these two, which is at x equals -1. Right? So let's look at the left-hand limit at x equals -1 and look at the right-hand limit at the x equals -1 and see what happens. Right? So let's say left-hand limit. If you're approaching from the left, you have to use the top formula, right? So if you plug in -1, so x is approaching -1, so it's going to be -1 squared, which is 1, minus 3. So that gives you 2. -2, sorry. All right, but if you're approaching from the right, you have to use the second formula. And if you let the x go to -1, so -5 plus 3, right? So which gives you, again, -2. So you can see that coming from both directions, the tendency is at going to -2. So they match up quite nicely. So there is no discontinuity at x equals -1, which means that there is no discontinuity at all, right? So the interval is going to be -infinity to, so negative, go to symbol, and infinity to positive infinity. All right, so let's check the answer. All right, I came back and looks like we got the first guy correctly. All right, so identify any discontinuities, but there is none. So we should probably put does not exist. All right, let's check the answer. All right, I came back and we got the second part correctly. All right, last one should be pretty simple. You see that there are no discontinuities, so f is continuous everywhere. So we click on that. All right, let's check the answer. All right, I came back and looks like we did all three parts correctly. All right, that's it. I hope that this was clear.